you're saying that there's no, you can guarantee that there's no relationship between what we experience, in terms of neurons and connection between neurons and what's actually going on, then why are you saying you're in favor of predictive processing? Because that's a theory constructed in terms of neurons and connections between them, which, according to you, has no validity.
Okay, welcome to the show. I'm joined here by Professor Donald Hoffman and Professor Anil Seth. To get started, I want to ask you both just to give us a brief introduction to your theory of consciousness. Maybe give us your working definition of consciousness and the major assumptions that your theories are built upon. So let's start this one with Donald, and then we'll move to Anil.
Okay. Well, I take consciousness to intuitively be what it feels like to experience things, to have a headache, feel love, and so forth. See the color green, taste chocolate. So the everyday common experiences, is what I mean by consciousness. Also, the sense of a self. That's part of being conscious. And I think that my theory of consciousness, going into it is quite a bit, but I'll say that of course, I'm a cognitive neuroscientist. I'm very interested in brain activity and how the brain functions and the relationship between conscious experiences and brain activity. And like Anil, I'm very much interested in predictive processing models of the brain and Bayesian inference models and so forth. So that all figures in what I'm thinking about when I think about the theory of consciousness. Also, I'm thinking about it in evolutionary terms, using evolution by natural selection to understand, the relationship of consciousness to the physical world and also modern high-energy theoretical physics. So I'm looking at how all these things work together as we try to understand what is consciousness in this relationship to the brain and space-time. And my conclusion, and I'm sure we'll have a fun discussion of this, is that, well, first, in agreement with Anil, I think that perception is a predictive process, so that we don't just see reality as it is, we see reality somewhat projected out there based on the priors that we bring to the situation. So not just the data coming into the senses, but our prior expectations. And so I've asked myself, what does evolution have to say about this? And what is the probability that the priors that are built into us would actually give us conceptions of the external world that are actually valid, that are actually tell us truths about the nature of objective reality. And we published a couple papers which basically say that it's a theorem of evolution that the probability that any sensory system has ever been shaped to see any aspect of reality truly is zero. So in other words, the probability that our perception of the world in terms of space and time and physical objects in space and time and things like brains and neurons, the probability that that's in any way remotely like the true nature of objective reality is precisely zero if we take evolution by natural selection seriously. So given that, my view is that, and then the other aspect of my view is what high energy theoretical physics is saying. They're saying now, in the last 20 years, that the probability that space-time is fundamental is zero. Space-time is doomed. So that space-time is not fundamental. Objects like protons, electrons, or even neurons inside space-time are not part of the fundamental aspects of objective reality. And they're finding new structures beyond space-time. So they're jumping outside of space-time just in the last 10 years. So this is not even well known by most physicists. It's this special branch of physics, high-energy theoretical physicists, who in the last 10 years have found what they call positive geometries. And it's now exploded. This month is the launch of a 10 million euro project, multinational project, to go after these structures entirely outside of space-time that are more fundamental than space-time. And so it's a revolution. And so when you look at evolution by natural selection and we look at high-energy theoretical physics, the idea that objects in space-time are fundamental just disappears. And that includes brains and neurons. So what I'm doing is looking at a theory of consciousness on its own terms. What is consciousness? Just can we give a mathematical model of consciousness, not as something that is secondary to neurons and rises from neurons, or secondary to some kind of integrated information substrate, and it arises from that. Can we give a theory of consciousness on its own terms? And so we've proposed a Markovian dynamical system model of consciousness, not as entities in space-time, not as entities deriving from some more fundamental substrate, but as entities that are fundamental in their own right. And then our goal is to start with this dynamics of conscious agents and show that it actually can give rise to the positive geometries that the physicists are finding beyond space-time. So that's our goal. A theory of consciousness outside of space-time that can then map into the positive geometries that have been found in the last 10 years. And then from that can give rise to space-time, because the physicists have done that part. They can go from positive geometries and give us space-time and physical objects in space-time. So the idea is to turn the whole story around. Consciousness is fundamental. Predictive processing is correct. We don't see the world as it is. We see it as we project it. And evolution says that our projection is an entire fiction. It's not anything like objective reality. It's just a useful fiction that keeps us alive. And so now the goal is then to have a theory of consciousness, qua consciousness, and show that space-time and brains and neurons arise from a deeper theory of consciousness, not vice versa. So I'm sure we'll have a lot to talk about, but that's top level, and we can then go into the details.
And just before we go to Anil, I want to ask Donald, if you don't mind, could you just, to make this more concrete for people, could you share us just a metaphor about the desktop user interface and its relevance for understanding of consciousness here?
Right. So an obvious objection to what I just said is, well, if evolution didn't shape us to see reality as it is, it certainly wouldn't make us more fit. Surely it's more fit to see something like the truth, as opposed to not seeing something like the truth. So how could you possibly have this theorem that says that evolution shaped us not to see the truth? It's obviously nonsense. And it's also self-refuting. We can go into that. There are philosophers who say that's actually a self-refuting argument. But here's a metaphor to help you understand. If you're trying to use a computer to send a photograph to a friend or send a text, what you're really doing, if you were looking at the innards of the computer, you're toggling millions of voltages in a precise order. That's what you're doing to actually send a photo to your friend. Now, if you had to actually toggle those millions of voltages yourself in a precise order to send that, you would never use it. It would never get done. So the user interface, their desktop interface on your laptop or your phone or whatever, is there to hide the truth. And by hiding the truth, it actually makes you more fit. It makes you more functional. It allows you to control reality. So you actually are toggling those millions of voltages, and you're toggling the way you want, the way you need to, but you don't have no idea what you're doing in reality. So that's what evolution did for us. It would have been too expensive to actually, for organisms to actually know all the details of reality they would need to know, would be way too expensive. So evolution does things on the cheap, and it gave you a cheap user interface that completely hides the truth, but allows you to control objective reality, even though you're utterly and completely ignorant about the nature of that reality. So that's the sort of the desktop or virtual reality headset. You can think of it as a VR headset interface as well. So
awesome. Thanks for sharing. Okay, Anil, I will move to you now.
Well, I mean, my ideas are going to seem very prosaic and mundane in contrast with this very poetic reconceptualization of physics, the universe, and consciousness and everything within it. But there are some points of contact for sure. So, I think the simplest way to start is with that point of contact. Don mentioned the idea of the predictive brain, predictive processing, and that's a good starting point for the way I've been thinking and working on consciousness too. And it starts from the idea that really, instead of trying to solve this mystery of consciousness head on as one big scary mystery in search of one big solution, like the Chalmers hard problem often sets it up this way, that how is it possible that physical processing, things like brains, bodies, whatever, give rise to or are identical to conscious experiences of any kind? That seems to be a very big mystery in search of a very dramatic solution. And Don is presenting us with a candidate solution, I think, to that in a sense, by finding some deeper layer that explains both. Now, I sort of start a little bit more pragmatically, maybe, by thinking that, okay, consciousness exists, and by consciousness, I mean the same thing Don means, that it's in the words of the philosopher Thomas Nagel, for a conscious organism, there is something it is like to be that organism. It feels like something to be me, to be you. And so it's not the same as intelligence or language or behavior of any particular kind. It's the raw fact of experiencing. And there are many different ways in which this is manifest for human beings, let's say, differently for other animals. We have experiences of the world around us and of being a self within it. How do we account for those experiences? This is where the predictive processing angle comes in for me. And the overall hope for me, I think this is where it's one difference with Don already, is that, I think just by using tools like predictive processing, predictive brain, to build explanatory bridges between neural circuits and properties of consciousness, we will dissolve this hard problem of consciousness. Even though if we don't directly solve it, it might just go away in a similar way to this apparent mystery of life mostly went away as people stopped searching for a spark of life and just got on with the job of explaining the properties of living systems in terms of physics and chemistry, which is what happened in biology. So I am agnostic about whether there is a hard problem, or if so, whether it can be solved. But I don't think it's necessary to attack it head on. I think we can go this pragmatic route of explaining the properties of consciousness in terms of mechanisms and see how far we get. And no doubt the questions we will ask will change, and the sensory sense of mystery may change and lessen as well. So that's the overall approach. The predictive brain idea is one pillar of that approach. There are other pillars as well, measures of complexity to try and understand changes in global conscious state, things like that. But the predictive brain is where I put most of my energy. And this is the idea, as nicely put by Don, that the world as it appears to us in conscious experience is not the world as it is. It's only indirectly related to whatever is really out there objectively. So I'm a kind of realist. I think that there is stuff out there, whatever that is. Don't really know what that is. Don's in contact with leading physicists who have ideas about that. But the brain is faced with this task of making some sense of the sensory signals that it gets in order to stay alive. And one way to do that is for the brain to kind of infer the most likely causes of its sensory inputs. And this is a sort of process of Bayesian inference, like how do I figure out what the most likely causes of the inputs that I'm getting? And one way to approximate Bayesian inference is to make predictions about what's out there and to use the sensory data to update those predictions. This is basically predictive processing, and there's lots of additional bells and whistles. But for present purposes, the key claim that I'm making is that what we consciously experience is not a readout of the sensory information. It's the predictions. It's this sort of outside, predominantly outside in, top-down flow of predictions that carries the content of what we experience, even though it doesn't seem like that. It seems to us, that the world is just there and we register it transparently through the windows of our senses. So this is very much in agreement with Don's point about this indirect experiential relationship we have. Then I think the same thing applies to the self as well. The self is another aspect of perceptual experience. It's not the thing that does the perceiving. It is an aspect of consciousness itself. And the way my thinking goes is that it's constructed by the same sorts of mechanisms. It's this dance of prediction and prediction error, but now the predictions are about the body, about the causes of self-generated actions, which underlie experiences of free will, about where the first person perspective is, and so on. And if you pull on this thread long enough, again, taking an evolutionary perspective, but in a slightly different direction, being able to make predictions about the causes of sensory signals is an extremely good way of implementing control and regulation over those causes and over those signals. And if we think about what brains are fundamentally for and what they likely evolved to be able to do, it wasn't to see the world as it is, or even really to see anything. It's to control and regulate the body, to keep the body and therefore the brain alive. So in my view, the reason we have predictive brains originated in light of this fundamental biological imperative for homeostasis, for allostasis, which is homeostasis over time, keeping the physiological condition of our bodies within the tight bounds compatible with survival. And this is an imperative that goes right down into the depths of our physiology, into individual cells. So a distinguishing aspect of the way I'm thinking is that consciousness is intimately related to our nature as living systems. It is not a kind of software program implemented on a meat-based computer that's wedged in between our ears. So there's this intimate relationship between life and consciousness. And that makes some predictions that living things, perhaps only living things, can be conscious. Certainly that we won't understand consciousness except in light of our nature as living creatures. And so I think, to wrap it up, by understanding, building models, so we take a kind of computational phenomenology approach in my group, at least partly, which is to build computational models that explain why particular experiences are the way they are, and why vision is the way it is and not some other way, why particular visual experiences have the character that they do. So we make models of visual hallucinations of different sorts. And we try and really, empirically elucidate this link between predictive mechanisms in the brain and the character of conscious experiences for human beings. And I think by doing that, then we will make progress on this problem of consciousness. And I think it is a bit of an open question, the extent to which the sense of mystery will remain or dissolve entirely.
Very cool. Thanks, Anil. No, you hinted at it there that for consciousness to happen, you require a living thing, or you require a living organism. And I think I'm not sure, but this might be a point of disagreement between you and Donald. So can we just maybe cover this? Like, Donald, what are your thoughts on this? Does consciousness require living organisms to happen, or is it beyond that?
Well, first, again, I agree with Anil about the importance of the predictive processing kind of approach and the constructive nature of perception and building computational models of that process. I mean, there's nothing better than actually building computational models where you say, here's how we construct this perception of space or this object or these colors or whatever it might be. You get down and dirty and actually build them. So yeah, we agree on that. I think that among the things that we build are, through perception, is when we open up skulls and look inside, we construct things that we call brains and neurons. Those are not exempt. Those themselves are also products of perceptual construction. And we have to ask, how literally should we take those things? Should we take, when we see neurons, when we look through microscopes, well, how, we know that perception is construction. What is the probability, given our understanding of evolutionary theory, that the neurons that we see when we look inside brains are in fact telling us, the perception of neurons is telling us something true about the world, namely that maybe there are things that we would call neurons out there in the objective world. And that's a clean technical question, right? It's not philosophy. We can ask, using evolutionary game theory, what is the probability that if I see a neuron, that means in objective reality, there are neurons out there?
I think that is a philosophical question. By the way, I'm not sure you answered Niall's question about the necessity of life before we get onto that.
Sure, I agree with you. So I should say the arguments I'm giving are going to support the idea that consciousness is prior to anything inside space-time, right? So I'm going to be arguing that brains and neurons don't exist when they're not perceived, and that for that reason, I'm going to then postulate that consciousness exists prior to even space-time, much less the contents of space-time. So that's why I was going for the evolutionary argument, to say that it's in the very structure of evolutionary game theory that the fitness payoff functions, so the fitness payoff functions that guide evolution, turn out you can prove that those functions almost surely do not have the information necessary to shape evolution to show us any aspects of objective reality, right? It's a theorem that the probability that any fitness payoffs contain information about any aspect of objective reality is zero. So that the predictive processing models, in fact, perhaps don't really capture how deep the issue is, that there's nothing in current evolutionary theory. Now, we may have to change evolutionary theory, but there's nothing in current evolutionary theory that gives us anything but zero probability that our predictive processing leads to anything that's homomorphic to the structure of reality. So to summarize,
I'm confused. Sorry, now we'll go, but I am a bit confused already, because if you're saying that there's no, you can guarantee that there's no relationship between what we experience, in terms of neurons and connections between neurons and what's actually going on, then why are you saying you're in favor of predictive processing? Because that's a theory constructed in terms of neurons and connections between them, which, according to you, has no validity.
Well, so the predictive processing is not primarily a theory about neurons. It's primarily based on Bayesian inference. So it's primarily based on, as you well know, I mean, you give lectures on this yourself about Bayes' rule and so forth. We then look for an instantiation of that kind of predictive processing within neural networks. But the theory itself is implementation independent, right? It doesn't depend.
I mean, Bayesian inferences, but predictive processing, predictive coding is typically, at least in my experience, taken to be a process theory. So it is taken to refer to the implementation, not to the overall mathematical framework. So I just want to be clear that, to the extent to which we agree, I think we both agree that there's a problem of Bayesian inference to be solved, but, I'm even a little unclear about what that means. If space-time itself is up for grabs, then why should we even be confident that perception involves a process of Bayesian inference about causes of sensory signals? But even so, that I think that predictive processing, predictive coding is, let's label that as a claim about implementation and mechanism. And so, is that something that you think stands up, or is that something you think is not useful because, again, it's based on a figment of our conception of what brains are made of?
Well, so in computational vision, so independent of neurobiology, there's a whole branch of visual, studies called computational vision, and also in artificial intelligence, where they're not interested in particular, physiological implementations, where they will also be doing this kind of predictive coding stuff, but not based maybe on artificial neural networks, but not based on anything specific to brains. And even more abstractly, there's many that just do the mathematics of Bayesian inference and just prove mathematically what the posteriors would be and so forth, without worrying about the details of an implementation in terms of computing units, right? So that there's the theoretical level, then there's in terms of Mars levels, right? So the computational theory, the algorithm, and the physical instantiation. And so I view predictive processing as more a computational level theory. But then the question about if space-time isn't fundamental, then how do I go there, right? So I view each theory as having its domain. So for example, Einstein's theory of space-time has a particular domain of application. But it turns out that Einstein's theory falls apart at 10 to the minus 33 centimeters, which is why the physicists, these high-energy theoretical physicists, are saying space-time is doomed and we need to go outside of space-time. So every scientific theory has its domain where it works, and then it necessarily has its limits. There's no theory of everything. So when I talk about predictive processing, I think of it in that scientific framework, which within its domain, it's a wonderful framework, but like any scientific theory, no theory is a theory of everything, and we'll always have to then say, what's the next level outside? So within one framework, Einstein's theory is wonderful, and we can do quantum field theory and do physics. But the physicists are now telling, the high-energy theoretical physicists are now telling, there's a deeper framework that will have Einstein's theory as a very special case, as a projection, and these positive geometries. And
Right.
so I'm saying the same thing. The predictive coding and all, in fact, cognitive neuroscience, which I am a cognitive neuroscientist, is wonderful within a particular limited framework. It is just that that framework, if you think it's fundamental, that's not fundamental. We have to go to a deeper framework in which we'll find that space-time emerges and neurons emerge as a projection of a much deeper reality.
Right. Now you're going to have to, steer us a little bit, but I mean, because this is going to run. But I mean, I think, I'm trying. I think, I get the points, and of course, theories are approximations. I mean, they're abstractions by definition. And one way to think, and I wonder if you agree with this. One way to think of it is where we place our explanatory bets, because it's already the case that we know, within neurons there are individual molecules, and there are deeper levels of description of neurons that we could appeal to, even without going to these new conceptions of space-time and positive geometries and everything. Yet, there's sort of some maybe collective explanatory bet, and it may be wrong, that focusing on neurons is a useful level of abstraction by which to understand how brains work and what they do. And it's not necessarily the case that the most fundamental level is the most useful level for a particular theory, for a given theory. Now, of course, it's nice, and it should be a requirement that these levels of description run through, that, one level of description doesn't contradict what might be happening at a more fundamental level. But there are reasons we have these different disciplines in the first place, because explanatory weights falls differently on the different levels. And of course, there's also an interesting mathematical frameworks of emergence and so on, where we can think of higher level descriptions, higher level properties of having real causal power in systems. And I think that's a very interesting area, but it just begs the question. Like, I place my sort of explanatory bets knowing that there are deeper levels of description, not knowing how low they go, recognizing that our picture of the brain is made up of neurons wired together is not actually how things are, but that it is a useful tracking of how things are that help in the explanation of properties of consciousness.
I want to ask about artificial intelligence soon, but before we do, Donald, something else I was curious to ask you about was, what do we know at this stage about what is beyond space-time? Like, what is there anything concrete we can say at this stage, or is it merely speculation?
Well, yes. So what has been discovered in the last 10 years is truly remarkable. They have found geometric structures beyond space-time and also beyond quantum theory. So there are no Hilbert spaces in these new structures. So there's no quantum theory. They found structures like the amplitude-hedron, associahedron, and cosmological polytopes, and then combinatorial structures that classify these things like decorated permutations. And what these things can do is remarkable. So if you try to understand, say, how two gluons smash into each other and four gluons go spraying out, and you do that using quantum field theory, things that happen at the Large Hadron Collider or at various colliders, particle collisions. If you do the computation of the scattering probabilities, scattering amplitudes inside space-time using quantum field theory, Feynman diagrams, that the one interaction, two gluons in, 4 to 6 gluons going out, is hundreds of pages of algebra for one interaction, millions of terms. So it's really ugly. When you do it with the new positive geometries, you compute the same thing in 3 or 4 terms. So millions of terms go down to 3 or 4, you get the right answer, and you see new symmetries that you can't see inside space-time. So what they're finding is the space-time is the wrong framework. It's in some sense unnecessarily complicated because it's a Rube Goldberg device in some sense. It's losing information about the symmetries and making the computations unnecessarily complicated. So letting go of space-time is actually the reason it's all of a sudden getting, I mean, this month is the launch for this 10 million euro push, international push on these positive geometries, because the results in the last 10 years are so stunning that they realize this is the way forward. So now, most of us in the neurosciences don't know that there's this whole group of high energy physicists who are saying space-time is doomed and reductionism is doomed. The whole framework of reductionism, they're tossing it out. I mean, if you're interested, there's a whole semester course at Harvard by Nima Arkani Hamed. If you just Google Nima Harvard Lecture 1, you can see he explains why the reductionist paradigm is dead and why space-time is doomed and why they're now going in with both feet outside of space-time. So yeah, it's not just a hand wave. This is the successes are so big in the last 10 years, and the structures they found are so stunning that now big funding agencies are funding multinational research on this. And I'll just say on the reductionist thing, I mean, Anil's point is very well taken, that within space-time, there are many, many levels at which we want to look at, the neurons versus, maybe molecular levels or so forth. But what this, and I agree within the space-time framework, absolutely that's the right way to think about things. What level within space-time are we doing our analysis? But what these guys are doing is upsetting the whole apple cart. They're saying space-time itself, including all of its levels, is not fundamental. There is no, in some sense, more fundamental level of reality within space-time, because space-time itself cannot be fundamental. It's doomed. That's their mantra. Space-time is doomed. It was first put out there, by the way, as far as I know, 2005 by the Nobel Prize winner David Gross, who won the Nobel Prize for his work in the strong force. So in 2005, he basically said space-time is doomed, and it's been picked up since then.
Okay, okay. Anil, can I just ask you to comment on the assertion that reductionism is doomed? Would you agree with that, or would you have any disagreements there?
Well, I'm not an expert on positive geometry, so this is above my pay grade. But there are, it's a couple of comments I think I can make about it. Firstly, I find it absolutely fascinating. I find all these developments in physics absolutely fascinating. One question is whether we need to go there. So, I think from my perspective, one has to have a very good reason for going beyond the methods, the mechanisms, the sort of constraints, if you like, of classical science, because they are extremely successful, and they allow us to make predictions about everyday phenomena, which may be the things that we want to explain from a science of consciousness, like why do anesthetics actually work? I think an explanation constructed in terms of things like neurons and chemicals and the stuff that is not fundamental, but it's connecting levels. It's connecting one level of description with another. And your explanatory power in general is sort of maximized at a particular distance between levels of description. If you go too far, you kind of begin to lose explanatory power. Again, it's a bit like, to use one of Don's examples, it'd be like trying to explain how Microsoft Word works in terms of voltage flows. You just don't get much explanatory insight that way, even though the voltage flows are more fundamental to the operation than lines of code. So yes, it may be that we need to throw out space-time and its dooms and whatnot, but it's not clear to me that doing so gives us additional explanatory power over the phenomena that we want to explain, because this has happened before in physics. For instance, we threw out a certain conception of space-time, a Newtonian conception, and replaced it with an Einsteinian conception, but it still meant that Newton is still used to do many, many things. It's not often you need to appeal to relativity to understand understand phenomena, and there are many phenomena where it's just not really relevant at all. So there's that question about utility and explanatory ambition. Reductionism is fascinating, and here it's something over which my thinking is changing quite a lot. One topic that I been interested in for a number of years and have sort of come back to after a period of not really doing much work in it, I think since the last time we spoke, Don, probably, is emergence. Now, emergence has got this it's a bit like consciousness, really. It's got this slightly disreputable flavor. What are you really talking about? Is it some sort of spooky thing, where things come into existence at a higher level that weren't there at the lower level, where you have downward causes that can influence lower level things and break this relationship of what the philosophers call supervenience. It's got this kind of disreputable air, and people go, "Oh yeah," but there's an everyday sense in which things certainly appear to be emergent. We look at it. We look at a flock of birds wheeling away in the sky, and the flock seems to have an identity of its own that is not evidently traceable to the individual birds, even though there's no mystery that a flock is made up of those individual birds. And so we've been working started this in 2010 and then picked it up a few years ago when a number of more mathematically able colleagues of mine started working on this too, to come up with measures of emergence that actually were practically useful and that captured this sense in which a whole can be more than the sum of its parts. And of course, when you start talking in those terms, then what's the relationship to reductionism? And the claim here, I think the way that I find most comfortable thinking here is that there's still reductionism holding in the sense that things flow through, things run through. Nothing happening at one level contradicts a description that would be made at a lower level if that description were made fully enough. That said, there's a definite sense in which it's reasonable to talk about emergent properties of complex systems, and one can do that in various ways. So one way, we use information theory to basically say a large scale variable, be it a flock of birds or something, is emergent if its dynamics. If knowing its dynamics is not improved by knowing the dynamics of the parts that make it up. There are various ways to do this, but we can frame them in terms of information theory, and they shed light. You can then talk sensibly about whether something is emergent, to what extent you can think of the macroscopic variable as sending information or influencing its microscopic parts, again, without breaking the assumption that everything flows through. So I think there's useful ways to think about emergence and reductionism. So ontologically, things have to flow through. There's no contradiction. Methodologically, there are many reasons to challenge reductionism. It's not, and this is not necessarily the case that the most fundamental level of description is the most useful. So reductionism as a philosophy of reality ontologically is different from reductionism as a philosophy of scientific practice. And I disagree with that, but I think we take issue with reductionism in slightly different ways.
Okay, interesting. Now, I want to move back to Donald here and ask about artificial intelligence. Can AI ever reach consciousness, do you think?
Well, the standard way of thinking about the problem is that, again, AIs are physical systems that a priori are not conscious, but if they have the right kind of physical complexity in their circuitry and so forth, then somehow the physical substrate somehow gives rise to the magic of consciousness. And so that's the way that question is usually thought of, and the way the answers are usually couched. And I reject that entire framework, right? So to be very, very clear, I think that space-time doesn't exist unless it's perceived, and physical objects don't exist unless they're perceived. So it's predictive processing taken to the extreme. They are there only in our experience and not otherwise. And so that way of framing, the standard way of framing the question assumes a physicalist ontology that I reject. But another question, the way I would then reframe it, of course, is our space-time is what is space-time then? It's a headset. It's a VR headset that consciousness uses, is the way I think about it. So in other words, I have to start with consciousness first. So consciousness is fundamental. And my explanations go from a mathematical model of consciousness to show how I get space-time and physics arising, and things like neurons and brains. So it's a different arrow of explanation. Instead of starting with space-time and physics, and getting an arrow explanation to get consciousness, I say, no, let's go the other way around. I'm going to start with consciousness qua consciousness, and I'm going to show that space-time and neurons come out as just one fairly trivial headset that consciousness could use among countless, many thousands, millions, trillions of other headsets. Space-time is just one, and a particularly, actually fairly simple one. So in that framework, then, what are AIs and what are machines? Well, I'll put it this way. Right now, I have certain portals into consciousness. Right now, if I look at the screen, I can see Anil, and I can see Neil, and I can see I have portals into your consciousness, right? Through your bodies, through your faces, and now on a Zoom screen, through certain pixels on my Zoom screen, I've got a portal into what Neil and Anil are thinking. Not perfect, but a genuine portal. So we know that there are portals into consciousness from this space-time headset. And we know we have one technology for making new portals into consciousness. The one technology that we do have is having kids. That technology works for making new portals into consciousness. So having kids is, I think that, yes, we could reverse engineer that and figure out how to make new portals besides the having kids approach. I think we could figure out how to make new portals into consciousness that's beyond space-time, and that the technology that we do may look like artificial intelligence. But in this case, it would not be unconscious circuits and software giving rise to consciousness. It would be consciousness using certain parts of its headset to open up new portals through that headset into consciousness, right? It's a complete. So in other words, I'm proposing that we need a completely different mindset. We're not building consciousness from anything inside space-time. Space-time in its complete total is nothing but a simple, trivial VR headset that some consciousnesses use. And that headset can give us portals into consciousness that are more or less clear. And we can develop technologies that open up new portals in that headset. So you can see my framework is entirely different.
Okay, that's fascinating. Now, Arnold, what are your thoughts on this?
Well, so many actually. I mean, I'm still fascinated by this very different perspective. I think just to comment a little bit on what Donald was just talking about. I think one issue I have there is if basically if the premise of every question, like, is AI conscious, or are other animals conscious, or are newborns conscious? If we chuck out the premises of all these questions, it becomes very difficult to answer them in a way that we can make use of in the world in which we live. So I think that doesn't mean that there's a wrong way to do it. It just means, I guess my motivation for being in this field is being able to understand, for instance, why anesthesia works. Why do people have hallucinations? What's the experience of free will all about? And to try and construct explanations that have contact with the rest of biology and cognitive science. Not exactly as it is. I'm very willing to explore more, not just neurons wired together, but other conceptions, but basically materialist conceptions. I think an unstated difference between us, hopefully an evident one, but still an unstated one, is that I would say a pragmatic materialist. I'm agnostic about the nature of fundamental reality, whether it's positive geometries or matter in some whatever complex form it is. But I'm a pragmatic materialist in the sense that making the assumption that stuff exists and has material properties has been extremely successful in resolving many of the mysteries we have that we want to explain about the universe, about life, about the mind so far. And I think I can do that, from an agnostic perspective. You can just follow that, see how far it leads. When it comes to AI, I think it's a very timely question. And it's important to be able to say specific things about it, because it's becoming, even a political question, like, is GPT-4 conscious? If not, could GPT-6 be conscious? And we need to have something to say about that question, even if it's not something you can say with 100% confidence or have credence in it. So Donna's absolutely right. The prevailing way to think about that question is that there's physical substrate organized in particular ways, and in some ways, consciousness is there too. Is generated by or is part of. I think we can sidestep that, but that's a typical way to do it. I'm very glad actually, Don, that you put it like that, because actually many people make an even stronger basic assumption, which is that consciousness is a form of computation or a form of information processing, and that conscious AI is simply a matter of either AI just getting smarter or programming some explicit model theory of the sufficient computational mechanisms for consciousness into an AI system. And I think I would say that's the most widespread view. Reading around the literature, people take this view of what's called computational functionalism rather for granted, that the brain is some kind of computer and information processing is the language, is the medium of consciousness. I think this is wrong, and I'm a little bit on a limb thinking this. But the brain as a computer metaphor, I think, has more or less outlived its utility now. There are so many ways in which brains are not computers, and information processing, I think, is best thought of as like an extrinsic viewpoint. We can use information theory as a generalization of statistics to describe systems. It doesn't mean that's what systems actually do. And so there's a case in which I also question this sort of premise, and the premise that I question is that computers, that get the information processing right and consciousness pops out. I think there's good reasons to question that, and they both come from three ways actually. The first way is understanding why we even think that AI could be conscious. We are so suckered in by our anthropocentric and anthropomorphic biases here that we project consciousness onto things on the basis of superficial similarities. We see consciousness where it isn't in many ways. We associate it with language and intelligence because we think these things are distinctive and human and special and specially related to consciousness. But consciousness is not fundamentally about language or intelligence. It's, as we both agree, about raw fact of feeling. So we have these biases, and then we have this assumption that computers could be conscious if you get the software right. And there are good reasons now to question this too, because they make assumptions about being able to realize what brains do in different substrates or in different systems. And there are actually very good reasons why that might not be the case. For the kinds of things that brains do, they're so complexly integrated and enmeshed that it's actually quite implausible that arbitrary other mechanisms could implement the same functions. And there's also a question about substrate neutrality, that silicon is as good as carbon when it comes to something like the mind and consciousness. Again, there are good reasons to challenge substrate neutrality. In a brain, you can even ask, well, where is the substrate? I mean, this gets a bit to Don's point as well. You can think of the neurons as the substrate and thoughts as the mindware or whatever, but really, there's no sharp division in the brain between mindware and wetware as there is between hardware and software in a computer. And then my own specific ideas tie consciousness very tightly to life. And so this really highlights one of the main differences between computers and living systems. Computers use energy, but they use energy to just map things from inputs to outputs, and they don't regenerate their own components through any process of anything like metabolism, whereas we do. And fundamentally, this process of predictive processing is grounded in metabolism. It's the individual neurons maintaining their physiological energetic exchanges with their surroundings. So if these ideas are on the right track, then conscious machines would need to be living machines. And philosophically, this is the position of biological naturalism. Again, I don't know if it's true, but it's an idea that I think deserves consideration, because showing that it's not true is also very, very difficult. So in brief, I think conscious AI is really much further away than most people think. And this is because most people assume it's just a property of information processing. And even worse, a property of intelligence, a function of intelligence. Having said that, we are already living in a world where we will be unable to resist feeling as if AI systems are conscious. This is already happening. We've seen examples of this, Google engineers and so on. And this is a near-term, just, I think, fact. We will live in this world, and even if we know or are very confident that a machine is not conscious, we will still be unable to resist feeling as if it is, in the same way that we can't unsee various kinds of visual illusions, even when we know what's going on. And there's a real social problem here, because how do we deal with this situation? Do we care about these AI systems as we would care about things that we feel are conscious? Well, if we do that, we're sacrificing human interests in the interests of things that don't have feelings. The alternative is that we learn to not care about these things. But this is also psychologically very dangerous for us. It will brutalize our minds in some sense. If we treat things as if they don't have feelings, even though we feel that they do have feelings. Kant, who I think is a predecessor of both of ours, especially of yours, in talking about the noumenon, the unknowable nature of physical of reality, which will be hidden behind always hidden behind a sensory veil, also talked about the brutalism of our minds in this sense. So there are dangers even to the discourse of conscious AI, even without its imminent reality.
Okay, okay. Well, Anil, at the end of your TED talk, you said something that really grabbed me. It was, when the end of consciousness comes, there's nothing to be afraid of, nothing at all. So I want to get both of your perspectives on the implications of your theories for our understanding of death. And I want to switch back to Donald, and then we'll come to you, Anil, for this one. Right. So Donald, can you give us your thoughts there?
Well, yeah, in a framework in which space-time is fundamental and somehow brains generate consciousness, then of course the death of the brain is the death of your consciousness, period. There's no question. In a framework in which consciousness is fundamental and space-time is just a headset, and that everything that you perceive is nothing but a virtual reality that you're projecting out there, right? This is predictive processing pushed to the limits. It's all prediction, the connection with reality. There is no isomorphism whatsoever with anything about reality. This is all a VR headset. So even the hands that I perceive right now are purely a construction inside my. It's like my avatar. If I'm wearing a VR headset and I see my avatar in a video game, of course, I could be taken in and identify with my avatar and then be worried if things are trying to hit my avatar and hurt my avatar. But if I realize I'm in a game and it's just my avatar, then I'm not too worried. So from this framework in which consciousness is fundamental and space-time is just a VR headset, then I don't know the answer, but at least it opens up the possibility that one answer to what is death is it's just taking off the headset. And when you take off the headset, of course you lose your avatar, but you don't lose your consciousness. So that's one way of thinking about it. Now, that's not why I am going after this, right? I mean, it's an interesting side effect. What I'm going after, the reason I'm going after this is also for pragmatic reasons, very pragmatic. And it may not seem pragmatic, but I'm going with consciousness first because we've so far failed. I mean, I know all the key players in the game, and they're brilliant. And we've so far failed to explain any one specific conscious experience, right? I time after time, asked Tononi and Hammeroff and various people. So, what specific conscious experience can your theory explain? Please, Stuart, give me one, specific conscious experience where in the orchestrated collapse of neuronal microtubule quantum states, that is the taste of chocolate or the smell of garlic. Can you give me even one? No. Tononi, can you give me one? IIT Q-shape, that must be the taste of chocolate or the smell of garlic. No, can't get. So I'm very pragmatic. I would like a theory that actually does something. So from my point of view, what I want to do is start with a theory of consciousness and actually predict scattering amplitudes. I would actually start with consciousness and get exactly the momentum distributions that the physicists have found for all the scattering amplitudes. In other words, I would like to be able to predict the headset from outside of. So I'm very pragmatic. I want to show how physics arises precisely when we take consciousness as fundamental.
Okay, Anil?
I think you're a little unfair on the state of consciousness science. I mean, saying we can't explain one specific experience is a little bit like asking an evolutionary biologist to say exactly why is this animal the specific way it is. I mean, you can give general things, but it's very hard to often hard to predict the specifics. And there are very interesting explanations of experiences happening. I mean, some of my own work at Sussex, we look at specific different kinds of hallucination. We have explanations for why hallucinations in Parkinson's disease are different from hallucinations in psychedelics. I mean, that's getting to a level of granularity that I find quite interesting, and those are grounded again in different tweaks to the predictive coding mechanism. Tononi in IIT says very interesting things about the phenomenology of space, for instance, why space has this, well, spatially extended character. Things in space have relations of near and far, and that makes some very interesting predictions about what happens when you inactivate specific parts of visual cortex. So I think it's growing, it's incremental, but there are predictions that make connection with the specificities of different experiences. Now, when it comes to this, the existential question of death, I'm also interested in this. Like, I think you said it yourself, Don, but in your view, well, yes, you lose the avatar when that aspect of the projection breaks down. Well, from the perspective, if you are right, then this question about death really pertains to the avatar. It doesn't make much difference to me as I experience being me, if I'm just an avatar or if there's something else going on. If that stops within this framework of space-time, well, that's typically the question about death that we want to know. So I'm not sure it makes huge amount of difference. I do think there is there are interesting ways to think about this question more broadly. So you're right as well that from a more prosaic way of looking at things, when the brain stops, consciousness stops. And the reason I think this is really important to connect that to what we feel about death is that many of us have had an experience of something like general anesthesia, which is as close to death as we'll ever get without dying. And consciousness for us, for each of us, whether it's an avatar or not, stops. I mean, there's no sense of time passing. You are gone and then you're back. So it's a little flavor of the kind of oblivion that I think is likely to accompany death. And there's nothing there. So the quote, there's nothing to be afraid of. Of course, that's stolen from a beautiful novel by Julian Barnes called Nothing to be Frightened of. And of course, there's a double meaning to it. I'm not afraid of it. There's nothing to be afraid of, and nothing is pretty damn scary. So we have this dual response to it, and that I left that deliberately ambiguous. But I think the not being afraid of it in the former sense, not existing at all, like the oblivion of general anesthesia. Well, of course, there's no suffering there. There's nothing at all. So why should we be afraid of not existing? We have this also temporal asymmetry. We don't seem to worry about all the time we didn't exist before we were born, but we seem very worried about FOMO of all the time that we'll miss in the future after we die. But yeah, the brain stops. Consciousness as we experience it as these self-constructions also stops.
Okay. Now just one last question to wrap up here. Arnold, I owe you a massive thank you. You won't know this, but basically whenever I watched your talk years ago, and I learned that our conscious experience is a combination of sensory signals from the environment and our brain's best predictions about what caused those signals, it made me take the idea of gratitude a lot more seriously and really focus on making sure the predictions of my brain were as accurate as possible, but also that I was really grateful for what I did have in my life. And that it wasn't a self-help talk, but it was the best self-help talk I've watched, so I want to say thank you for that. But the question is, what are the practical implications of both of your theories on how we live our lives, and how has your approach to life changed whenever these understandings became known to you? So Donald, can we go to you, and then we'll conclude with an Anil here.
Well, the idea that we're not just objects in space-time, of course, is not new, right? The spiritual traditions have been saying that, mystical traditions have been saying that for thousands of years. And but they've not had any rigorous science behind them, right? So we've had mystical traditions saying this stuff, but it's been the physicalist science that gives us technology, and so is sort of the got a lot more belief from average people. So, but I think now we're in a position where there's a possible convergence where we might be able to actually use the methods and mathematics of science to actually talk about consciousness prior to space-time. And so who knows, that may lead to all sorts of interesting convergences where we actually, right, the spiritual traditions talk about what their words are just pointers. You don't take the word seriously, they're just pointers. The reality transcends any pointer. Well, the nice thing about scientific theories is, yeah, they're just pointers too. But the nice thing about scientific pointers is they tell you their limits. Einstein's theory of space-time tells you that it stops at 10 to the minus 33 centimeters. It's over for space-time. So our science tells us this theory has this scope and these hard limits, and every theory in science will have its hard limits. So I see going forward that the implication personally may be that there could be an interesting dialogue between science and spirituality. I've already been involved in talking with the Dalai Lama and Deepak Chopra and various spiritual traditions, Jewish as well as Sufi and others. I mean, so and Christian. So it's very interesting. And again, in the same spirit, I take my science, which is respectful but hard-nosed, right? You have to be respectful and yet hard-nosed, because ultimately we need things to be logically coherent and also to be consistent with data. So perhaps going forward, there'll be a very personal payoff in which we can get the best insights from the mystical traditions, give them a more rigorous framework, find out what parts of it are worthwhile and what parts are nonsense, and move forward on a personal level. So science and spirituality may not need to be at odds. They may actually have a synergy that could lead to a very personal, helpful stuff. And I'm sure there'll be surprises for both in the process.
I listened to your conversation with Rupert Spira, and it was amazing to see the synergy between your thinking coming from completely different backgrounds, so I definitely
Yes.
think there's something there.
Yes.
And Arnold, what are your thoughts on this question?
Well, I certainly agree with the complementarity. It's a great thing to see. It was one of the motivations that got me into this area originally was some of the original connections between Buddhism at that time and neuroscience. So people like Francisco Varela beginning dialogues with the Dalai Lama. And now I think that's reaching out to other traditions as well. Now my family's Indian, and there's a Hindu concept of Maya, which is super interesting. It's often thought of as illusion, but actually, I think more accurately, it's sort of that aspect of the world that gives us the impression that our experience is real, which I think is a really interesting take on it. And there is a convergence. So even before we get to the nature of space-time, there's insights from Buddhism returning to Buddhism about impermanence, the changing nature of the self, the indirect nature relationship between experience and reality that line up very, very closely. And of course, the benefits are also therefore complementary as well. So, meditative practice cultivates an attitude in which we can recognize this indirect relationship, this impermanence to some extent. And that for people, I don't have the discipline to meditate for the time required, but it can be extremely beneficial in alleviating suffering just because you don't get sucked into this, assuming that what you experience reflects how things actually are and how things actually will be. Thoughts pass, self changes. So these are all, I think, very, very valuable insights and have practical implications. So for my own personal lived experience, of course, I don't have the control Anil Seth who did something else to compare against, but I do think it's changed how I live my life. I do spend time and I do catch myself thinking, as I would just walk around the world doing the washing up or picking up some food from the grocery store, that what I'm experiencing is not really what's there. It's a construction. And there's one project I've been working on in particular, I'm very excited about, cashes this out in a very specific way, which is that we all have different brains, so we will all experience things differently, even for the same shared objective reality. And we're familiar with this from, other animals clearly have very different umwelts, will have very different perceptual environments, but human beings too. And I think we overlook this diversity. We recognize it with terms like neurodiversity, but they tend to get associated with conditions like autism and ADHD. And because it seems to us that we see the world as it is, and because we may have sufficiently similar experiences, that the differences are glossed over with language. Now, we overlook the fact that we have different experiences, individual ways of seeing. And the novelist Anil Seth put it very nicely. We don't see things as they are, we see them as we are. And we have this project that I've been running in collaboration with Fiona McPherson at Glasgow and Collective Act in London, where we've very large-scale citizen science projects where we've got 35,000 people each doing probably an hour or up to 5 hours of detailed experiments to characterize individual differences in many aspects of perception, in color, in time, in music, in rhythm, in the impact of expectation. So lots of different dimensions to try and surface for the first time, really. There's been lots of small-scale studies of individual differences, typically looking at one aspect of perception or trait psychology, but we're trying to understand the big picture here and bring to light a richness in the diversity of our inner worlds. And I do think this is relevant to society now. In one sense, there's a parallel with biodiversity here. We're familiar with the idea that a flourishing ecosystem needs many different kinds of species. So a flourishing society, if this analogy holds, needs a variety of different kinds of ways of seeing. And then on top of that, recognizing that the way we see things is not the way things are and not necessarily the way others see them, can engender a very useful humility in how we see the world. And that humility in how we see things, and this is my idealism, not the philosophical idealism, more the societal idealism shining through, optimism, let's call it for avoidance of confusion, that humility that we might cultivate about our way of seeing can also cultivate a humility about our ways of thinking, about our beliefs, and help push back a little bit against the dynamic of polarization and echo chamber that we find ourselves in. Getting out of an echo chamber requires knowing that you're in one. And most people don't know that they're in a perceptual echo chamber of their brain's making. And if we can recognize that, then you might wonder what other echo chambers you might be in, and have also just greater empathy and understanding of people trapped inside their own echo chambers without realizing it.
For sure. Well, I want to say a huge thank you to you both for your time today. It's been absolutely fascinating to speak with you. We've barely scratched the surface on either of the two of you's work. So
there's no surface now. There's no surface. The surface is a figment from space-time. Come on. Will you not listen?
But for anyone interested in a deeper dive, I recommend picking up The Case Against Reality by Donald and Being You by Anil. I'll link to them in the description for this episode, so definitely to get a copy of those. So thanks so much, guys. I really appreciate it. And I want to wish you the best with your research and everything going forward too.
Thank you.
Thanks so much. It's been a pleasure.
Always a pleasure, Anil, as well.
Likewise.
Okay. Thank you, Neil.
Thank you very much.
Thank you for listening, and I hope you enjoyed the show. If you'd like to hear the full version, you can do so with the Weekend University Premium membership. This gets you access to our mastered library of over 5 years of psychology conferences, including over 230 talks and interviews with the world's leading psychologists, professors, and authors, unlimited CPD certification, transcripts, quizzes, premium passes for our annual conference, online courses with Richard Schwartz and Deb Dana, and more. The cost is £97 for 1 year, which breaks down at around 27p per day. The best bit is you can try it out for 30 days completely risk-free, as all orders come with a 100% money-back guarantee. If you're interested, please go to twmembers.com for more information.